Welcome to video number 24 in how to make a chess program in Go. Last time we looked at the transposition table and made the code for that. This time we will use it. First we need to initialize some values before we start the search. And that is we increment the age and set some counters to 0. And if we have a best score in the root, okay, we will save that. If depth greater than or equals 0, and that's in fact right now it's always greater or equals 0. I don't know, we will play around with depth later on when we make reductions. Maybe it can be less than 0 here. I don't think so, but we never know. I just put that test here. So we use the full key, and we need the move and the depth and the ply. And the ply is always 0 when we are in the root, and the score type that I will explain in just a minute. We move this sort outside after the search like this, because we have a sort in the beginning of each iteration, so we don't need one in the end of each iteration. And here we store, if we store the best move. I use depth -1 because I don't trust the last depth, because normally we use move time or game time or something, and that last depth will not be a full depth. Of course we could check that, but I do this right now. And we save the best score and the score type. We need a function to compute the right score type. And it's compared to best score compares to alpha and beta. Okay, we can remove this one. When we made the QS function, I didn't show where to use it, but it just replaces the evaluate we had here before, and we do QS instead in the beginning of search. I have my little comment to help myself. Here we will put retrieve. So it's we start to initialize some values. Trans move is the move we get. Trans depth is the depth that we use in retrieve. PV node is principal variation node, and the formula I use here will not work until later, but I put it here, otherwise I will forget it. So it has no meaning right now, but later on it will. If depth less than 0, and that can be so when we make extensions. And I need to see if we're using check here. And then we set trans depth to 0. We will never have less than 0 depth in the table. Okay, so we make a block here just to, I don't want to think about conflicting variable names, So I use a block around this trans table retrieve. So we have the score that we get from trans table from retrieve, and the score type and OK that we will get from the retrieve, and we will use the full key as a key. So here is the retrieve. If trans move, trans score, trans type and OK, that is what we get from the retrieve, and we call with the key and the depth and the apply. So if OK after that call, then we can use the score, and we skip if it's not PV mode node. So we have a switch with 3 cases. Score type is score type lower, and trans score is greater than equal beta, and we will have 3 different cases here. And we will have a score type upper, then we will be less than and equal alpha, and score type between will be here, and we can remove this one. So score type, what is that? When we save in the transposition table, when we use a store, the score we have that is either of type lower, a lower bound, or an upper bound, or an exact score, and that is compared to alpha and beta. So if it's a lower bound, type lower, then we know that it cannot be lower than this. It will be this value or more. If it's an upper bound value, it will be this value or less. And if it's between, we have a score between alpha and beta, and we use that as an exact score. That is when we store. So now when we get the new score from retrieve, if it's a score type lower, we check if it's still lower in this search, and if it's like that, okay, then we can use that. And the same if it's an upper bound. If this trans score less than or equal to alpha, then it's an upper bound, and we can use that. And the same with between. Something is wrong here, yes. So when we have one of these 3, it's a prone. I have these temporary counters. So we just return this score in all of these cases. Spelling error here. This prone is just to make a health check on our table later on. Okay, all these 3 cases we return trans score. I should learn how to spell. Oh my god. Trans score. Trans score. Trans. Okay, my fingers like SN and not NS. Okay, this is the retrieve. Now we need to store somewhere, and that is when score is when we have a new best score. I have my little comment up there. Yeah, we should have the store there. So Transp store. And we use the full key. We store the move, the depth, the apply, score, and score type. And we can compute the score type here. Alpha, beta, this will be a lower bound. Anyway, when we have a cutoff, I check if it's moved from the trans table. In that case, we make a count, a prone count again. And I think I have something further down. In the end of the search. This is not actually a prone, but it's a best move in the end of the search. It's an all node for sure. I think I didn't explain that. All node, cut node, and other types of nodes. I will do that. After this video I will have a short explanation of different nodes, because it's useful to know that. It seems like the BM best move doesn't, it's out of the scope here, I think. So let's go up and fix that. So we have a best move here. Put the best move in the beginning, and now we have a best move. I have made some changes in this yin in order function, so the trans move is always in the beginning, but I will not even show that code because it's nothing I'm proud of. Just to have something to test with. The next step is to make a better move generator. Okay, I think that's all for this time, and see you next time.